Hey everybody, this is Larry. This is day 9 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Yeah, I told you last week that I was going to put in the snowboarding thing, so I'm going to put it in right now. Feel free to fast forward. It's just me doing a little bit of things in the park. I need to get a little bit better one day, but just still working on it. But Okay, so welcome back. I don't know. Let me know what you think. I'm working on it. It's only my third trip in like 10, 15 years, so still a little bit rusty. And a lot of it is honestly mental. Like physically I can do things, but it's tough. It's been so long. I'm not comfortable, right? And what I mean by the tough part isn't the physical part, because I could almost certainly do it, do harder things, but it's just about not wanting to fall. When you don't want to fall, you're not going to get up, and it's hard to make progress. Of course, that said, there are different ways that you can do it in a safer way, right? But still, I'm talking about just very basic things. Because, for example, you can go to a trampoline park. You can, maybe you see videos of people doing like jumps into like a foam pit and stuff like that. And I've done it before. It's kind of really fun. Annoying thing is that they don't really have that in New York, but that's another story. But stuff like that, allows you to practice in a safe way, right? Which, trying to do in the park, I already messed up my shoulders a couple of weeks ago, and it's still kind of like iffy. It's a lot better, but I still don't have like strength in certain angles, so I don't know. Anyway, this is a little bit of a long intro because I want to give people an update on just everything, I suppose, on the workouts. I still have a half marathon next week, so this week I'm going to try to run as much as I can, or reasonably can, and then we'll see. Okay, let's take a look at today's problem. We have 3129, find all possible stable binary arrays 1. All right, that means I guess we'll do 2 later maybe. Let's take a look. We have 3 positive integers, 0, 1, and limit. A binary array R is stable if the number of 0 is 0. The number of recurrence of 1 in an array is exactly 1, Each subarray of R is with a size greater than limit must contain both 0 and 1. Yeah. Oh. This is the variable name. I was like, what are they saying? I was so confused. I don't know. I feel like they can name these things better, Like it's like naming just like Larry or something. No. You name it a person, not Larry. This is terrible variable naming. Or just call it like X or Y. Like honestly, if this is X and Y, this would actually be, more understandable somehow. But in any case, okay. I was like, what is the problem on here? So confusing. Well, maybe I just have reading issues. I don't know. Anyway, let's take a look. Each subarray R with a size greater than limit must contain both 0 and 1. I don't know what that means necessarily, but we'll see. Return the total number of stable binary arrays. Since the numbers can be very large, we have mod. If I can type it out correctly. Mod. Right? Oh man, the stock markets are doing not great. Yikes. But yeah, okay. So let me take a look at some examples. So limit, okay, so limit doesn't have to be 0 plus 1. So why does that, what does that mean? What is limit? Each greater must contain both 0 and 1. What's a stable number of stable binary? Okay. Man, am I just not reading this question correctly? Oh, 200, that's interesting. But I don't even know what it's asking for. Okay, so is it just means that you cannot have? I see. So this part just means that any array of length limit cannot be or greater, but it also just means that you cannot have a streak of limit zeros, or maybe limit plus one, whatever, right? Because if that's the case, then it doesn't have a one by pigeonhole, actually, right? Okay, I see. So that means that the length is going to be 0 plus 1. Yeah, let's just call it x and y. Or maybe L, count, C, count 0 and count 1. I feel like, it's slightly better. I don't know if it's better, but I mean, it is definitely better because it actually, instead of, I don't know. But okay. All right. So then n is just equal to count 0 plus count 1. Okay, right? And what it's saying is that we cannot have limit number of zeros in a row, or maybe it's either it cannot have more than limit in a row, right? Okay, so I mean, I feel like that's a standard dynamic programming problem, maybe, right? It's just take note, but right. So you have ones left, maybe, or zeros left. Let's do 0 left, 1 left, 1's left. I don't know. Is that grammatically better? And then a streak, right? But streak could be one or the other. But before we write, right, that's just like an idea. So then, before for dynamic programming for memorization problems, sorry, this one took a while, but to kind of just read it correctly. But for memorization ideas, the important thing is to, just figure out the complexity, right? So zeros left is going to be 200 at most, one's left is going to be 200, and then streak is going to be also at most 200, kind of, maybe 400. Well, there are two ways to do it, right? You could either use like positive, negative, or you can just have what you call it. You could just have another variable of like last is 0 or 1, right? So this is the last thing, right? And then what's the question here, right? So that's the number of possible states we might have. Let's do a last used or something, right? But inside the loop, it's probably fine, right? In that we just have two things, right? We use a 1 here or use a 0 here. So that's going to be constant just because there are only two possible things. So this should be complexity wise is okay, but it might actually be too slow because, that's just was it 16 million, right? So I don't know. So we'll give it a try. Maybe it's too slow because Leetcode issues. Complexity wise, it is going to be, just, I wouldn't say it's n cubed because n is kind of weird, but and we don't even need this, I don't think. So I don't know. But right. So we count 0, count 1. The streak is 0, and then the last used is, I don't know, just use a -1. It doesn't really matter, right? And I'm doing this like cache clear thing. This is Python specific thing, and maybe Leetcode specific thing, right? So then now we just have, right? Let's do base case first, right? So f is equal to 0, and 1's left is equal to 0. Then we return 1, right? Otherwise, otherwise, right? So, how do I want to write it? You can write it more specific, right? So you try to use a 0 here, and then use a 1 here, or try anyway, right? And then you can just start by doing count is equal to 0. But if zeros left is greater than 0, and so obviously you need to have zeros left, or well, I mean, you still it's an n. And the streak doesn't go over, right? And either um, either last used is equal to 1, meaning that we have a new, so we have a new thing, so the streak doesn't matter, or streak plus 1 is less than or equal to limit, right? So something like this. And of course you can do a for loop, because if you're really careful, because this one is going to look very similar, but that's the idea, right? So then now we just add it to f of well, we use 1, we we don't change here, and then the streak is either going to be streak plus 1 or 1, right? So do we do ternary? Let's just add another if statement, right? Or I guess if we're going to split it out anyway, we can just make it whatever, right? Because if we're going to have to write it out again, then maybe that wasn't really worth doing, right? So then we could just do this. So it's right? If last use is equal to 1, else if, right, this thing, right? This is an or. So if last use is a 1, then streak going to be reset, so it's a 1, and the last use number is a 0, right? Otherwise, same thing, right? To begin with, and then it's just streak plus 1, and then we still have a 0 either way, right? And the 1 is going to be look very similar, but in the opposite way. So let's write it out. And of course, maybe we'll just do the mod here. So we only do one mod. With 1's left is greater than 0. Oops. And it's very easy. You just saw me almost made a typo here, right? It's very easy to make a typo on these things. That's why maybe for loop it's a little bit better, but I don't know. Maybe I'm trying. I want to say maybe this is more I don't know, easier for teaching, but I don't know if that's true, honestly. But right, something like this. So let's give it a quick spin. Well, I mean, I don't know. These inputs are very basic, so maybe we could try something bigger, like, I don't know. Well, let's just try 200, 200, 200, right? If nothing else, just to see if it kind of, runs fast enough. And it might not be, to be honest. Memory limit exceed is kind of annoying. That's what I was worried about more than the time limited. Because the number of states, it's going to have 16 million, and I don't know. It's just annoying. I mean, the answer on how to fix this is just to convert it to dynamic programming, or to bottoms up, and then probably use the space optimization trick, which is kind of very annoying. All right. We know that this is going to fail, right? Or just because of the memory limited. Of course, we just test it. We'll test it again just in case. I don't know. It's a little bit wonky or something. Alright, but I am going to intentionally submit it just so I have it on record. That's all. Like, I did it correctly last time. That's actually surprising. But, yeah. But maybe it's just because, this is, oh, wow, we were actually very close. But yeah, that means that now we have to convert it to bottoms up. And I'm just kind of dreading it just because it is just, like, it's just more work for no payoff, so it's a little bit annoying. But, how do I want to write this? I mean, there is also an optimization that you can think about doing, but I'm trying to think. Give me a second. I mean, we can definitely do it bottoms up, but there's like a yeah, there's but I don't know if I want to teach it. It's annoying. Hmm. The idea being that yeah, I mean, this is kind of hard to draw out as well. All right. Well, this is a medium. Am I missing something? That's the reason why I'm like thinking whether I'm like being dumb in something, which may be true. This is the naive solution, right? Naive DP solution. But I'm also thinking like for medium, this should not be that crazy. Maybe I'm missing like a dimension somewhere. I'm trying to think. Can I get rid of one of the dimension, right? I mean, maybe, probably not last year's. I mean, you can't really get rid of these two and probably not this one, so it probably a streak, and I'm just trying to think, what's another way of expressing the streak, right? Man, and it's been a while, I don't remember. Kind of bad at these. The annoying thing is that they make the bounce so that it's close enough for this to pass, but okay, let's think about this. So then we have to do, right? But okay, so maybe another way I'm thinking about it now, right? And there are a couple of ways you can think about it, right? This is clearly the in dynamic programming, this is pro-dynamic programming. And then another way to think about the push dynamic programming might be something like if we have zeros left, ones left, right, and then we have last used, right? So then maybe we have push. So let's say we have something like this as a DP, right? We have this value. Then what do we update, right? This is the push. So we would update. Okay, we have a streak of. So yeah, you would write something like this instead. So the reason why we have streak is so that we could unroll the loop. But because of memory, maybe we can do a loop instead, I guess. Right? Would that be fast enough if we just actually? I mean, we could do it with push as well, but I'm curious whether I can just get rid of this for space issue. and then maybe we can just write some, and maybe that's why I'm like being dumb. I mean, this is maybe too I don't know if it's optimized, but optimized for speed and not thing, right? Because then now let's say we have this as the thing, then now what, right? Well, now the occurrence, I mean, it's still going to be similar-ish, right? So then now, okay, we have count, right? So then we use a 0 here. So then here it's the same thing, except for now last used, we yeah, actually this is just correct. Oh well, not the streak anymore, we don't have any streak. And then now we can just say for well, this never is true anymore, right? There's a little bit weird double negative going on, but that's okay. We're just gonna explore for now, and if it's correct then maybe we'll clean it up. I won't, but yeah, so then streak of 1 all the way to limit. Is it limit inclusive? Well, I forget. Right? Or limit inclusive, I think. So then now it is just going to be equal to this, right? So once left, and then we don't have this, and then the last number is 0, right? Of course, we have to check that 0's left is greater than equal to streak, right? And this if statement is not necessary anymore, but it's fine. We'll just do it for, you know. And you could also probably, instead of having this number, you could just put it into the range. Right. And we'll do that actually. So it's min of this or 0's left, right? Is it 0 left plus 1, I think, inclusive. So yeah. So then you have something like this, right? And then now this is going to be mostly the same. Same changes, right? Sometimes you just have blind spots, I guess. Well, I do anyway. So something like this, right? Give it a quick spin. I have to fix this. Yeah, okay. And we'll see if it's fast enough, or, well, correct enough. What is wrong? Maybe I do this wrong. One streak is going to be... Wait, what did I get wrong again? Well, I want to see which direction I'm going wrong, meaning I want to see if I'm undercounting or overcounting. But it's a good sign that this is fast enough, right? Because we you know, maybe I mean, likely we're just doing it off by 1. So if it's fast enough, then we have a possible, or I guess the other thing was fast enough, but whether it uses enough, or because you're trading off a little bit memory for speed, so that's why we worry that it's going to be fast enough, because we know that we cut the space down by 200 factor. So right, but yeah, I want to see if we're going up or down, right? Because if we're overcounting, that means that you know, this is overcounting in a way, so we can check that. I think that's because this 1 is no, so 1's left is 1, then it'll be 1 to 2, so that should be right? Why am I? I see. No. What am I? I mean, it definitely is like one of these things, but I don't know. 0's left, 1 1. What am I doing wrong? 1's left. Now we change to 1. And of course, by the way, now that we notice this, you can actually do another trick, which we will not use for now. Well, because it's just not even correct. So why would we use? Okay, let's audit, because we suspect this is incorrect. So then maybe we can write something like, if streak is less than or equal to limit, and streak is less than or equal to 0's left, right? And also do the same here. Still wrong in the same way. Am I missing the streak thing? Streak is, I always do 1, so it's not that. Huh? I'm kind of confused actually, to be honest. It's limit. Did I do limit wrong? Greater than limit, right? I mean, let's try. Did I just misunderstand limit? Huh, no, this is undercounting then. Am I overcounting or something? I mean, I am overcounting, but how am I overcounting? I don't even know, to be honest. Oh, this is wrong. Oh, I see. Because what I just did a lazy thing. I just didn't really because if the last use is 0, we let it happen again to extend it for some reason. And the reason is because we just kind of use the same structure we had before, which is totally incorrect. I needed to reset myself brain-wise to kind of do it, right? Because then now, because what we should have done, and I say we because I messed up, is that if this is not equal to 0, then we can use 0, right? And then now we just do this. We don't do the thing about, I don't know what the other thing is. It doesn't make sense, right? Because we will never try to extend the previous streak because we don't have a streak anymore, right? And the reason why I wrote this in a double negative kind of way is because so that we can do -1, and when we have -1, it triggers both on 0 and 1, right? So if it's not 1, then we can use a 1 here, right? And that should be okay. That is kind of sloppy actually on my part. Hopefully this is good. And of course also fast enough, right? So let's give a quick submit. It may be too slow now, but we will see. Hopefully not. So then I can, maybe that's, I mean, yeah, I guess that's how, that's funny that I did the optimization beforehand, right? And actually I just remembered that, this is kind of slow. I just remembered that there's a part 2. So maybe I was going to go over an idea and a technique, but honestly, like I said, this is part 1. Maybe there's a part 2 tomorrow. If there's part 2 tomorrow, then we'll go over part 2. Well, during part 2 tomorrow, right? Yeah. Alrighty. Yeah, okay. Yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. Oh, let me go with complexity. What am I doing? Sorry. I mean, this is the same idea, right? Except for we got rid of this for space. And what I mean by that is that now this is no longer an input thing, right? So then now we have, it's kind of funny that like I did it like the more I wouldn't say optimized. It should be the same, but a little bit faster. But then it ended up being not the thing that you. But yeah, how many inputs, right? It's gonna be 200 times 200 times 2, right? And you can maybe even say, let's just say x times y times 2, right? Big O, which is gonna be O of x times y, where x is number of ones and y is number of zeros. Well, the other way around. Whoops. I mean, it doesn't really matter, but. And then for each input, we do a loop of L. L is limit. So this is going to be O of x times y times L, kind of times 2, but you could get rid of 2 and a big O, right? And that's it. That's all I have for this one. Let me know what you think. Thanks for watching. I guess that's how, I mean, this is a more natural solution for a even more naive. Now, and I was going to go. That's why I kind of paused, because it was just a medium. The idea that I was thinking of was going to be like a little bit insane. But yeah, and it's kind of tricky. Sometimes you just get stuck in the wrong place, and that took like 14 minutes for me to resolve. Yeah, because then now, with this as the visualization, and maybe we don't even need this anymore actually, and maybe that'll be a little bit faster as a result. Let me run it real quick. Because that wasn't the issue anyway. Yeah. Let's give a quick submit. Because those if statements do add up. Maybe even only 1 min per function, right? So yeah. Okay, well, I mean, half a second is not nothing. But yeah. Yeah, okay. That's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.